Okay. So we want to integrate from 0 to 4. Okay, and we know the answer ahead of time. I just want to show you how you can do this, how you can see this on the graph. If we go to menu, and let's see here. To be honest, I didn't do this beforehand, so yeah. So we'll go to Analyze Graph, we'll go to Integral, and we go to our lower bound. Isn't that cool? Go up to 4. Now, why doesn't it say exactly 4? Well, do I have it exactly at 4? You know, that would be the question I have for myself. Did I get it to be exactly at 4 here? And if I don't have it exactly at 4, it's not going to show up to be. So I would use this cautiously. Now, what I was looking for, and it could be that it's one of these, the programs, one of the TNS files, the activities I send you, that has it built in. And that may be where I was thinking about it, where it does the same thing, where we look for the integration and it automatically will do that. But yes, what we're looking at then is going from 0 to 4, and it does shade that. Yeah, Lindsay?
Is there a way you can type in the numbers?
You know, what I would probably do, let's see here. I'm going to put a point on, and I'll put a point on here, and, you know, go through that little routine. Interesting, it didn't come up with the coordinates, did it? Okay, so we'll get the coordinates there. You know how usually we get the coordinates of that point. So we should be able to put a point there and have it just be able to put it to that point, and it would then go immediately to that. Okay, so there it is. There is now all of section 5.2 wrapped up in an example here showing how we would use that. You don't want to have to go through all this work, do you? I mean, you like to make things difficult for yourself sometimes, but you don't want to do this. You really don't. Okay, but that's the work. That's the limit definition of integration. So let's go now to another problem here. This is just using one of those properties that says if you want to integrate from you want to integrate from from 2 to 4. And we know the integration of x cubed from 2 to 4 is 60. We know the integration of dx. Now this is kind of curious. This is just the differential. Where's the function? Where's the function on that? Okay, so let's look at this. If I'm going to evaluate this, I could evaluate that from 2 to 4, and I remember I can multiply those. I can break those into multiple integration problems. Okay, so this is the integration from 2 to 4 of x cubed dx plus the integration from 2 to 4 of 2 dx. But now this is good. I mean, I've got my area under the curve of x cubed from 2 to 4 is 60. So, you know, this is the same thing as 60. But what about this? I'm given this, and then the problem throws me this. Let's go back to my original problem. What's the function? There has to be an integrand in here. What would that integrand be? Make sure I was recording here. Is it 0? If it's 0, then you don't even have a dx there, a differential x. So I would say it's 1. If it's 1, so let's break that out. If it's the integration from 2 to 4 of 1 times dx is equal to 2, what am I going to do with this 2? Well, that's 2 times 1. What does that make 2 then? Another scalar. Yeah, it's another scalar. So this is 2 times the integration. Okay, so let me write another step out here to show that. So this would be the integration from 2 to 4 x cubed dx plus 2 times the integration from 2 to 4 of 1 times dx, or simply dx. So there is a function there. It's 1. We don't usually write 1, but it's 1. It's not 1x. Okay, it's not 1x. It's just 1. What what's the graph of that function? What's the graph of the function f of x equals 1? Just a horizontal line. Okay. You're at 1, and we're going from 2 to 4. So what would the area under that curve be? 2, yeah, and that's what it says. Okay, it's 2. Okay, so now I want twice that, and so this would be 2 times 2. Our answer would be 64. So let me show you another way to use your Inspires to check your answers. You need a calculator page for this one. So let's put a calculator page up. Go to Menu. Go to Calculus, and the third one down is an integral. Now, on the indefinites, I said we're going to ignore the upper and lower bounds. We're not going to ignore them now. What's the lower bound? What's the upper bound? 4. Okay. What's the function? Yeah, it's the integrand there, x cubed plus 2. Okay, so I'll type that in. And this reminds us we have to put that differential x. Okay, so you input variables x. Our answer should be what? There it is. Okay. So now you've got another way of checking. You don't have to do the graphical way. You can if you need to, but you don't have to. Okay, let's go on. Given the integration from 0 to 3 of f of x dx is 4, the integration from 3 to 6 of the same function is -2. Now this is interesting. The fact that it's -2 tells us something about where the output values are. Below the input axis. Whatever this function is, it dips below in this case. Determine the integration from 0 to 6. You've got 0 to 3, 3 to 6, so the integration from 0 to 6 is going to be what? Integration from 0 to 3 plus the integration from 3 to 6. (4 plus -2 would be then a net. Actually, yeah, a net. Let's see, I always get net and gross mixed up. Net is what you bring home, because you net it and bring it home. Gross is what you have overall. So the gross would be 6. Now again, because this is negative, I can tell you that this portion of the graph is falling below the horizontal axis. And so what we end up with, we have a portion above and then something below. It could be something like that. We know the area here is 4. Because this is below, it's -2. Now, when I have a chance to discuss this with the students, a little illustration that I try to give is, suppose that you own land, and the land lies, some of it above the highway, and some of it, north of the highway, some of it south of the highway. If you want to know how much area you have in that land, then you would use if you knew what curve this was, or if you wanted to estimate using rectangles, you could estimate using rectangles and find out that this is 4, but because this is below the input axis, it's a negative quantity. Do you truly have negative quantity land? No. So in order to find out the gross amount of this, we would take the opposite of whatever is below the curve. Okay? Now again, that gets us into section 5.6, but that's the explanation of why this was a negative. It's below. And again, there are times when we don't want the net, which is 2, we want the gross. How much is it total without the signs on it? And it would be 6 in this case. Okay. Now, this, I believe, is, I have in my notes, is part of homework. So I'm not going to go through, and this is only a portion of it. I'm not going to go through it completely with you, but I do want you to have a chance to think about it here in class. This portion, and it may be hard to read back there if you don't have the notes in front of you, it says it goes from 0 to 2. So we have 0 to 2. So this is 0 and this is 2. So the region we're looking at to find the area of is this right here. Now it says evaluate using geometric formula. What geometric formula is this portion? I heard half a circle, and I can't take that. What? A fourth of a circle. Yeah. Yep. So it's 1/4 pi r squared. What's the radius of that circle? 2. So if we knew the shape of, if we had the function for this, we could come up with, now, because it's below the input axis, that means that analytically, you're going to come up with a negative answer. However, if you just want to know how much land I have, I don't care if it's above or below, north or south, you would then take the opposite of that answer. But the fact that it's down here means that it's going to be a negative. Okay, so section 5.3 is the bridge. Okay, the bridge of everything we've done now, and we're going to get into section 5.4. So let me save this, get this all finished up here.